So, if you've ever found yourself needing to run thousands or heck, even millions of AI prompts all at once, you definitely know the pain of just waiting. Well, today we're going to dive into a feature that's built to solve that exact problem: batch inference in Amazon Bedrock. Think of it as the difference between hitting the drive-thru and placing a full catering order for all your AI jobs. I mean, just imagine it. You've got this massive data set, right? Maybe thousands of documents you need to summarize, a folder full of images to classify, or a ton of customer reviews you need to analyze for sentiment. How are you going to feed all of that to a foundation model? Sending them one by one by one? Well, that's just a recipe for a very long day and a lot of headaches. Let's stick with that food analogy. Making individual API calls for each prompt, that's literally like going through the drive-thru for every single person at a giant party. It's slow, it's inefficient, and you're just repeating the same steps over and over again. Batch inference, on the other hand, is like placing one single massive catering order. You just hand over your list, they prep everything all at once, and they call you when it's ready for pickup. It's fast, it's asynchronous, and it is built for exactly this kind of scale. In that analogy, it really gets to the heart of the matter, the scaling problem. So let's really dig in and see how this catering order approach, this batch inference, is the solution. So what is it really? To put it simply, batch inference is a feature that lets you hand over a gigantic pile of prompts to Bedrock in one single request. And the magic word here is asynchronously. You don't sit there and wait for the responses one by one. Nope. You submit the job, you go grab a coffee, and Bedrock just churns through everything in the background, dropping all the results neatly into an S3 bucket when it's all done. The actual process really does follow our catering analogy. First, you place your order by uploading all your prompts in a special file to an S3 bucket. Second, you tell the kitchen, Amazon Bedrock, to get cooking by creating an inference job. And finally, you get the call that your order is ready, with all those delicious results waiting for you in another S3 bucket. Pretty straightforward, right? Of course, just like any big mission, before you can hit the launch button, you gotta run through a pre-flight checklist. So let's go over the absolute essentials you'll need to have ready to go. There are really just 4 non-negotiables here. First, you need 2 S3 buckets, one for your input data and another one for the output. Easy enough. Your input data has to be in a very specific format called JSON-L, which we'll look at in just a second. And finally, you have to set up what's called an IAM service role. This is what gives Bedrock permission to actually access those buckets for you. All right, so the key to this whole operation is that input format, JSON-L, which stands for JSON lines. It's basically a simple text file. But here's the trick. Every single line in that file is its own complete JSON object. This structure is fantastic for processing huge data sets. And each line needs 2 things: a record ID so you can track it, and a model input object, which holds your actual prompt. And here's what one of those lines actually looks like. You've got your unique record ID. Think of it like an order number for that one prompt. Then, inside the model input, you put the exact same request body that you would send if you were making a normal one-off API call to the model. Now, I know that last item on our checklist, the IAM role, can feel a little abstract, so here's a great way to think about it. The IAM role is basically a security badge that you create and give to the Bedrock service. This badge gives it just enough permission to read from your input bucket and write to your output bucket, all on your behalf. It's the proper, secure way to delegate that access. All right, our prep work is done. All systems are go. Now it's time for the main event. Let's walk through how you actually run the job from the moment you press go to the moment it's finished. You kick things off in one of 2 ways. You can either use the AWS console, or, more likely for automation, you'll use the Create Model Invocation Job API call. Either way, you'll need to give it a few key details: a name for your job, the ID of the model you want to use, that IAM role we just set up, and of course the S3 locations for your input and output. And once it's up and running, you're not in the dark. You can easily track its progress. The job status will tell you if it's in progress, completed, failed, or maybe stopped. It's just like getting those updates from the kitchen, so you know exactly where your massive catering order stands. And the job is complete. Now for the best part, the mission debrief. Let's pop the hood and see what Bedrock actually delivered to our output bucket. So when you look inside your output location, you're going to find a structure that perfectly mirrors your input. For every single input.jsonl file you gave it, Bedrock creates a matching output file, and each line in that output file has your original record ID and your input, plus a brand new field called Model Output, which, you guessed it, contains the model's response. It's all perfectly tied together. But that's not all you get. There's also this incredibly useful little summary file called manifest.json.out. Think of this as your job's final report card. It tells you everything you need to know about how the entire batch job went down. And when you open up that manifest, you'll see these key metrics. You get the total record count, how many of them succeeded, and just as important, how many of them failed. And this is huge for anyone watching the budget. It gives you the total input and output token counts for the entire job. That is fantastic for understanding your costs and analyzing performance. Now, you're probably wondering, okay, this is cool, but am I stuck using just one specific model for this? And the answer is a big, resounding no. Batch Inference supports a huge variety of models. You get access to models from pretty much all the heavy hitters you'd expect. We're talking Amazon's own Titan models, Anthropic's Claude family, Meta's Llama, Mistral AI, and a whole lot more. This flexibility is key because it means you can pick the absolute best tool, the best model, for your specific large-scale job. Okay, now for a quick pro tip. For those of you who are already living and breathing in the OpenAI ecosystem, Bedrock actually has an alternative way to do this that's going to feel right at home. You can actually use the OpenAI compatible Batch API directly with Bedrock. The workflow is a little different. Instead of the AWS SDK, you just use the OpenAI SDK you already know. Instead of an IAM role, you authenticate with a Bedrock API key. And the output? It gets delivered to a folder right there inside your input bucket, not a separate one. It's a fantastic option if you're looking for a really smooth transition from that ecosystem. So when you boil it all down, what's the crucial point here? It's this. Batch inference is the thing that takes you from small-scale AI experiments to massive production-level workloads. It transforms what would be a slow, painful, unmanageable flood of individual requests into a single, efficient, asynchronous job. And what does that mean for you? It means you save a ton of time, a ton of effort, and ultimately, a ton of money. This really is a fundamentally different and frankly better way of thinking about large-scale AI processing. So with this kind of power right at your fingertips, the only real question left is, what huge, repetitive, time-sucking task are you going to automate next?